All right, so today we're going to cover one section, 1.5. And if you have a book and want to join me on page 55, that's where the problems are going to be coming from, page 55. And this section is on intersections, unions, and compound inequalities. Intersections, unions, and compound inequalities. Yeah, it's got a long title. Let's see. Who is that just came in? Jalen? All right, so we're going to start with problem number 3 on page 55. Let's see. And the instructions say find the intersection or union. And so the first thing that you're going to have to be able to determine is whether this is an intersection or a union. And that deals with the symbol that's in the middle, okay? So if this symbol is an upside down, it looks like an upside down U to me, doesn't it? Yeah. Okay, that is the symbol for intersection. If it's a right side up U, just remember that U stands for union, okay? So that's the way you can tell whether it's an intersection or a union, is whether this symbol in the middle makes a U for union, or if it's upside down, that'll be intersection. Got that? Yeah. Okay, good. So, and just for math trivia, okay, see if I've mentioned this before. Does anybody remember what the name for this fancy bracket is? Brace. Good. And remember, braces are used to indicate a set. So this is the set of letters A, B, C, D. And this is the set of letters B, F, G. And we want the intersection of those two sets. So intersection means, what do they have in common? Is B the only thing they have in common? And so the answer is the set containing B. The intersection of two sets is what they have in common. Got it? All right. So let's play the what if game. Y'all ever play that in high school? Get your teacher off track? You know what I'm talking about? Well, what if this? Well, what if this? Yeah, okay, so what if it would have looked like that? So now what symbol do we have in the middle? Union. And union means take all the stuff that both sets have and put it into a single set. It's like saying take the two sets and combine them and take everything that they both have. So what would the answer be for the union of those? A, B, C, D, F, G. Can you do B squared? No. Okay. A, B, C, D. F, G. F, G. Whoop. And I spazzed out on my brace. And I want you to notice that these two sets both contain the letter B, So if I write B in the union, that takes care of both of those. You don't have to write B twice. You just basically put them all together. And if something appears repeatedly, you don't have to repeat it. Okay, so if I go through and look at this set that I wrote down, I should be able to go, okay, this one is here, this one is here, and here, right? But it takes care of both of them. And then C is represented, D is represented, F and G is represented. Everybody over here has to be represented in the union. Now, does that make sense? It's almost like if you move in with somebody and they say, well, I've got a couch, and you say, well, I've got a couch, and we're like, we don't need two couches, and so you just keep one couch, okay? Is that better? Okay. Next problem, number 7. Oh, I'm so sorry. This was number 7. Huh. I thought I was doing a what if, and it was actually number 7. Okay, so much for number 7. Do y'all think if I give you a problem that you can do intersection or union?
Sure.
You do?
Sure.
Okay, let's see. I'm going to make one up, okay? All right, so what I've done is I've picked 2 sets that I enjoy doing. This first set is the first 5 even numbers. Did y'all notice that? Those other numbers are the first 5 some other kind of numbers. Anybody recognize those? Yeah, those are the first 5 prime numbers. 2, 3, 5, 7, 11. Y'all know what prime numbers are? Numbers that can't be divided evenly by anything but one in themselves. So a prime number, nothing goes into a prime number except one in itself evenly. So let's look at the intersection of the first 5 even numbers with the first 5 prime numbers. And what do they have in common? 2. Which is actually kind of interesting. Did you know that 2 is the only even prime number? That'll get you a free drink at the bar. You know, I bet you can't tell me the only even prime number. Yeah. And then, of course, if we did the union, we would have a lot of them. So let's also do the union. All right, so call out the union.
2, 3, 4, 5, 6, 7, 8, 10, 11.
2, 3, 4, 5,
6, 7,
6, 7,
8, 10, 11.
And did that get everybody represented? 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. Who's the only guy left out? 9. He's excluded from the union.
So the top number is the intersection?
Yeah. This one right here, that's intersection. And the one that looks like a U is union. Okay? And intersection takes where they overlap, and union takes everything. All of it. You know what I'm saying? Okay. Are y'all ready to move on to the next new thing? Okay, let's move on to number 19. Number 19. How many inequalities are there? 2. You need to know that this is called a compound inequality. When there's 2 inequalities in the same problem, that's called a compound inequality. Are y'all making a note of that? You need to know that. It'll make you a better citizen. And you need to notice the word they gave you in the middle. And means intersect. And is the same as saying intersect. So we're going to have to solve both of these inequalities for x. Here we go. Plus 7 comes over. That's going to become 4 minus 7, which is -3. And then we're going to have to divide both sides by 3 to get x by itself. X is greater than or equal to -1. So far, so good? Next, -5 moves over. Now, -5 becomes +5. What is 5 minus 1? And divide both sides by 2. X is greater than or equal to 2. So far, so good? Okay, now, let's take that information and go to the number line. We want to graph that result. So I've got 2 critical points. -1 and +2. And does it matter what order I write them in? Oh yeah, it does. Big time. Are those critical points going to have open circles or solid dots? What's the difference between what?
Solid dot and an open.
Oh, okay. Do you see how this inequality has the equal to part? That determines whether it's open or solid. And the difference really between open and solid tells me whether that number is included in the solution or not included. Okay, so if it's equal to, then it's going to be a solid dot, which means that -1 is part of the solution set. If it was an open circle, -1 itself would not be part of the solution set.
So if we had a 0 and a 1 in there in between, we could put an open circle on that?
What do you mean, in between here? I'm not sure about in between there yet. All I know for sure is that at these critical points, I'm going to have solid dots. And then after I get those points nailed down, then I need to shade left or right. So from -1, I'm going to shade to we're going to shade the way the arrow points as long as the letter's on the left, okay? So from -1, we're going to shade to the right. And do you see that it shades all the way off the end of the number line? From +2, we're going to shade to the right because it also points to the right. And he's going to shade all the way off the edge of the number line. And does anybody have any questions at this point? Anybody? Do you understand once you get your solutions, that tells you your critical points and which way to shade them? Now we need to consider whether we have and. We need to consider if we have an intersection or a union. What do we have? And remember, intersection takes what they have in common. When you're looking at a graph, you can say it's the overlap. Where do the graphs overlap? From 2 to infinity. So the interval notation for this solution is going to be bracket 2 to infinity.
Why do you have a square bracket on the left and a round bracket on the right?
That's a good question. And I guess Luis is going to answer part of it.
What'd you say?
Infinities always have a parenthesis.
So if you have an infinity, it's going to have a parenthesis. But the 2 is going to have a square bracket depending on whether his dot was open or solid. So if it's a solid dot, you get a square bracket. What if it's an open circle? You get a parenthesis. Now, do y'all know the meaning, the different meaning between bracket and parenthesis though? Okay, so if you have a square bracket, that says everything up to 2 and including 2 is part of the answer. In other words, 2 is included in the answer. But if you have a parenthesis, that says everything up to but not including 2. Everything, like as close as you want to get to 2, but not including 2 itself, if it's a parenthesis. Okay? And again, just to use a reference for where that fits in the real world, that's taxes. Okay? If you earn up to so much money, you pay a certain rate. But if you get to exactly the certain amount, then you get moved into the next bracket. Okay, so it's like up to $14,999.99, and then once you get to $15,000, boop, and they move you over. Okay, does that make sense? Up to and including, or up to and not including? Okay, never mind. Anybody have any questions on what I've done so far?
So would our final answer just be the one at the bottom, or would it be everything shown?
1, 2, 3 parts to the answer. Yeah. And plus, I could throw in another piece if you want another piece. I think I will. Y'all like getting bonus stuff for free, don't you?
Yes.
Okay. And you're like saying, wait a second, I don't know about math, though. I don't know that I want more math for free. We could also write this answer in set notation. Have I mentioned both of those notations in class yet? There's set notation and there's interval notation, okay? So set notation always has the braces. Set notation has the braces, okay? And this will be the set of all x such that, and this is going to tell me what x does, okay? Now, can y'all see, according to the interval notation, x has to be anything from 2 or bigger. So we could say the set notation would be the set of all x such that x is greater than or equal to 2. Greater than or equal to 2 means this. Greater than, and the bracket says equal to. All right, who wants to do another one? Yeah, me too. But does anybody have any questions? All right, let's move on and do another one. 33. We've got negative 18, negative 2x minus 7, and 0. All right, so tell me how many inequality symbols are there? And that makes this a compound inequality, okay? But did you see this one is all strung together? There's not an and or an or in the middle. And so this is going to be an understood and, because when they string it all together, that's going to be an and, understood, okay? And how many variables are there? I only see one. So we're going to need to isolate the variable. So let's start with add 7 to all 3 sections. And what does that do for me? Why would I add 7? To get rid of the negative 7. Remember, whatever you do to one side, you have to do to the other? But here there's 1, 2, 3 sides. So whatever you do to one section, you have to do to every, it's like whatever you do to one side, you have to do to the other, okay? But you have to do it in this case to all 3 sections. And the reason I did plus 7 is to get rid of the minus 7. So negative 18 plus 7? Less than or equal to negative 2x less than 7. And do y'all see how that moves me one step closer to getting x by itself? And now what do I need to do to get x by itself? Not add 2. And why is it divide and not add? Because it's understood multiplication. That's negative 2 times x. And so the opposite of multiply is divide. And how many people noticed that I divided by a negative number? Is there anything I have to remember about inequalities? So the inequality has to flip. If you divide by a negative, the inequality flips. You're going to have to remember that. Negative over a negative makes positive. So far, so good? Y'all will let me know if you have a question, right? You're paying a lot of money, ask me questions. You better ask.
And why do we flip?
If you divide by a negative.
Why did we divide by a positive?
Say it again.
Why did we divide by a positive?
Why did we? Or
Why did we not?
Because to get rid of the coefficient, you have to divide by the coefficient. So whatever that coefficient of x is, that's what you have to divide by. If I divided by positive 2, I would still have a negative x left.
Oh, okay.
And I can't have a negative x, so that's why I had to divide by negative.
Okay.
Okay? Now, if you want to go deeper into it as far as why do the signs flip because we're dividing by negative, you're probably going to need to take some higher level math to understand that. All right? Now, let's use some color. Let's go with blue first. And this says x is greater than negative 7/2. Do y'all see that? The blue part? And I said that these that are all strung together, it's an understood and, okay? And look at the green part. That says 11 over 2 is greater than or equal to x. I don't really like the x being on the right-hand side. So can I take the green circle and flip it? I want to take this and flip it around so that it says x is less than or equal to 11/2. This is going to be a lot easier to graph on the number line if I separate it into 2 separate inequalities. Does everybody see how I did that? And the fact that the green circle, when I flip it, the inequality still has to point to the x. Okay, so now let's go to the number line.
So, Professor,
Go ahead.
your preference is always that, or is that a rule, or is that a preference that the x is always on the left?
It's a preference. And here's why, okay? If I keep x on the left, I always shade the way the inequality points. So I know that from negative 7 over 2, I'm going to shade to the right. But from 11 over 2, I'm going to shade to the left. And that's why I prefer the letter to be on the left. All right, so we've got 2 critical points, negative 7/2 and 11/2. Are those going to be open circles or solid dots?
Actually, 1 over the 11.
Okay, so the 11 over 2 is solid, but the negative 7 over 2 is open. Everybody see why it's one of each this time? Because the negative 7 halves doesn't have the equal to part. So he's an open circle. And then we're going to shade, okay? And what does and mean again? Intersect, which means where they overlap. So the negative 7 halves is going to shade to the right, but the 11 halves shade to the left, and they're going to overlap in the middle. So I'm only going to shade the middle because that's where they overlap. If I got I could have shaded off the ends, but I still would only take where they overlap. Why do I only want overlap? Because it said the word and. It's an intersection. Now let's write the interval notation. What is shaded? Everything from negative 7 halves to 11 halves. The negative 7 halves gets a parenthesis. The 11 halves gets a bracket. And that is my interval notation.
Okay, I'm still confused, I guess, on the brackets and why one gets a square one and one gets a round one.
Open circle, parenthesis. Open circle.
Oh, okay, so infinity gets the roundy bracket.
Infinity always gets a parenthesis.
Always, okay, and so then anything that would be an open circle also gets the parentheses.
Right, so the undo, I don't want that to look like that. So this guy produces an open circle, and an open circle makes a parenthesis.
Okay, so just remember open circle and infinity parentheses.
Yeah.
Okay.
I don't know, does that help any or not, drawing those arrows? The fact that this doesn't have the equal to makes it open. The fact that it's open makes a parenthesis. This does have the equal to, makes it solid. Solid is a bracket. Okay, and I'm thinking that it might be fun to do the set notation again. Just for fun, let's do the set notation. And so what does set notation always start with? A brace. And then an X. And then the line. And then the rest of it is what X does. And we can simply say 11 halves X negative 7 halves. Do y'all see? I simply took this statement right here once I have X by itself, and I copy and paste that over here. That tells me what X does. How are we doing so far? Good? Okay, let's go to another one. And I'm going to add a page. Number 49. How many inequalities are there? Again, this is a compound inequality. And this time they have the word or. And what does or mean? Union. And is intersect or is union. And remember, union means not just the overlap, you take everything. Every ounce of shading we're going to take, okay? So we're going to have to solve for x twice. So here we go. Moving the plus 5 over makes it a minus 5. 7 minus 5 is 2. And then divide both sides by what kind of 4?
-4.
And y'all do understand we have to divide by the number with the letter, correct? The coefficient of x. I'm dividing by -4. Whoops, I'm dividing by a negative. The inequality has to flip. Oh, and that's not nice.
So will it flip back if we switch the excavator?
Yes,
Okay,
yes it will.
left it the way it was. Okay, got it.
Yeah, so this is going to be a double flip. Because y'all see I divided by a negative makes the inequality flip. But now the letter's not on the side I want it to be on. So now I'm going to take the whole thing and flip it around. And that's going to say this. If I flip it around, the alligator still has to eat the x, right? Okay, now let's put the word or. And let's do it again. Here we go. Plus 5 becomes minus 5. 10 minus 5? And divide both sides by? Whoops, I'm dividing by a negative. So that's now going to point this way. And the x is on the wrong side. So we're going to flip it again. And why is it a good idea to keep x on the left?
So we know which direction to shade.
Yes, so you know which direction. It's easier to know which direction to shade, okay? So now that I've solved, let's go to the number line. I've got 2 critical points. Which one is the leftmost? -5 over 4 is smaller than -1/2.
It's gonna be a solid.
I heard somebody say it's going to be a solid. Yeah, the -5/4 is a solid. What about the -1/2? It's an open. So far, so good? Which direction am I going to shade from -5/4? To the left. So -5/4 shades to the left, but -1/2 shades to the right. And does everybody see that these 2 shadings do not overlap? There's no intersection. If they don't overlap, there's no intersection. There is a union though, okay? Here's what it looks like in interval notation, okay? Remember that union, the word or, union, means that you take all of the shading, even if it doesn't overlap. You're still going to take all the shading. So where does this shading start? On the left. And since it's on the left, it's -infinity. And the shading continues up to -5/4. And the -5/4 gets what symbol? A bracket. And then we're going to put the union symbol. Because the U is the glue that sticks the 2 pieces together. The U is the glue. It sticks the 2 pieces together. What symbol does the -1/2 get? Parenthesis. -1/2 to and beyond.
Incoming message.
Oops, that was me.
How can there be a union if there's no intersection?
how can there be a union if there's no intersection? Okay.
Isn't-
Let me explain that in real people words, okay? Did y'all hear that? How can there be a union if there's no intersection? Let's say that we have two human beings, two people that want to get married, but they have nothing in common. Can they get married if they have nothing in common?
Yes.
Marriage is a union, right? You can have a union without an intersection.
That's cool.
Yeah. And I got to tell you, this stuff really relates closely to people stuff, okay? Because when you're dating, it's an and statement. When you're dating, it's an and. You're like, oh, we have so much in common. And then you get married and you find out, dude, we got some stuff we don't have in common, right? Yeah, that's why they call marriage a union, because you got to take everything, the good, the bad, the kids sometimes. Take it all.
So why did that interval notation? Why did it start with the parentheses?
Right here,
Yeah.
because it started with an infinity.
Oh, infinity always starts with a parentheses.
Infinity always gets a parenthesis. And why did it start with negative infinity? Yeah, because the interval notation describes what is shaded from left to right. And so if I say, where does this shading start on the left? It has no starting point on the left. So that's why it starts at minus infinity. So what do we have there? We got the solution, the graph, and the interval notation. Okay? And let's play the what if game. Y'all like the what if game? Okay, let's play the what if game. What if I would have arrived at this solution, but the word in the middle was and? Okay. Because you see, if they would have said and, I would have to have overlap. Because and takes where they overlap, but these two shadings never overlap. Therefore, we're going to get no solution. And this is the symbol for no solution. Everybody understand that? If they give you the intersection symbol, or if they use the word and, your shading has to overlap. If it doesn't, you've got no solution, okay? Let's see. And now do y'all feel pretty confident that if I give you one, you could do it on your own? You do? Okay. So let's see if I can pick a nice one here for y'all to do. Okay, I got it. Number 57. There you go. I would like you to solve, graph, and write the interval notation for that solution. Solve it, graph it, interval notation. On your mark, get set, go. I'll give you a couple of minutes. Oh, and I'll give you a hint. You have to get rid of those fractions first. First thing you got to do is get rid of those fractions. Troy. I forgot Troy. Juan Goodman. Chris Hamlet. Wes. Devin. Juana. Ah. Jasmine. Hey, look at that. They weren't all absent. No. Eliminate it. Not reduce it, eliminate it.
You have to reduce it to eliminate?
Nope. You're going.
Understanding this.
Anybody still working on it? It looks like a lot of people are waiting for me to start.
Yeah, could you give us one that's kind of like the one we were just doing? It's like so. It's like really good.
What do you, that is like the, it has an or.
But the fraction.
That's just one additional step. You're getting rid of that fraction.
No.
I tell you, give them a fraction and they freak the freak out. When really it's a easy fix. Easy fix.
Making it my own math.
You're not allowed to make up your own math.
It's working for me. It's working.
You're not allowed to make up your own math. Maybe I'll just give you the first step and then you can take it and run with it, okay? Now, how do you get rid of a fraction? Multiply by what?
-6.
Multiply by the denominator. So you need to multiply both sides by 6.
Not negative?
Nope,
Why not negative?
because it won't eliminate the fraction if you do negative.
But to cancel out the 6 on the bottom.
But you see the 6 on the bottom is positive.
Right,
So if you want it to cancel, you need to multiply by itself.
by itself.
Because 6 over 6 is 1.
See, I made up my own math.
What? I think it's going to have an answer. I really do. Yeah, so you're going to have to multiply both of those inequalities by 6 on both sides. There, I bet you can take it from there then. It was just the fraction was scaring you. But do you see how freaking easy that was to get rid of the fraction? You just multiply by the denominator. And it cancels the 6's out. But whatever you do to one side, so that's the -3 had to get the 6, and the 4 had to get the 6 also. There you go. Now take it and run with it. And I can tell you for sure that if you're given an or compound inequality, if it has or, it'll never be no solution. If it has an and, it can sometimes be no solution. 6 in the bottom cancels it out. You've got where are we at? Yeah, but this, there's no 6 to multiply by the 5 because this 6 cancels this 6. These 6's cancel, there's nothing. See, this, when this 6 and this 6 cancel, there's nothing left to the two. Wait a second, what is negative 18 plus 5?
We're not.
What'd you get? Did you check on your calculator? You lost it. Wait, it's negative 18. But.
That's when they're negative.
And then this will be negative 13. That'll be your first time done.
I don't get how you got 2.4 on this side wasn't.
I didn't get you.
24. Oh.
Oh, it looks like a point.
Oh. It looked like a dot.
You know what that dot is? That's my pen cursor. It just happened to stop there.
Oh.
All right, I'm running out of time. I got to finish it up so we can finish this up today. Here we go. Negative 5 becomes plus 5. Negative 18 plus 5 is negative 13. Divided by 2. X is less than or equal to negative 13 halves. Or what is 24 plus 5? 24 plus 5? 29 divided by 2. X is greater than or equal to 29 halves.
Do you reduce that at all?
If it would reduce, you reduce it.
To even or improper? Or does it matter?
I like it improper, but if it'll reduce, you need to reduce it. 29 halves won't reduce, neither will 13 halves. So now to the number line. I'm sorry, are there any questions on those numbers, how I got them? Do you see the math? Now, on the number line, we got negative 13 halves. That's a solid dot. 29 halves. That's a solid dot.
Incoming message.
I'm sorry, that'll stop in a minute. Shaded to the right, shaded to the left. And do y'all see that these two shadings do not overlap? But it's an or, so it's okay if they don't overlap. So what is the interval notation? Everything from, I see a hand up.
Backtrack on that 2x minus 5. Why did you keep it a negative 5?
Here?
Plus 5. Oh, never mind.
Did you answer your own question?
Nope, got it.
Okay. What symbol does the negative 13 halves get? Bracket. And then I need union. Remember, the U is the glue that sticks the two pieces together. Bracket. 29 halves to and beyond. And that is the answer I needed. The solution, the graph, the interval notation. And you're going to need to know how to do that on your own.